Hi, welcome to our pre-calculus. Today's topic is review of equations. We are going to go through a set of ideas that are probably familiar to most of you, just so that we are clear on our terminology. So first item here is what is meant by a formula or an expression. Here's an example of it, x squared minus 3. Notice that I'm not making any statement about it. It's just a so-called well-formed formula standing all by itself. An equation is when you compare two entities and look for values of the variable that make it a true statement. So an equation reads like something equals something else. An inequality is a comparison in which you say that a quantity is more than something else, or more than or equal to something else. That is when you're dealing with an inequality. An identity, we came through this concept before. We had a lot of trigonometric identities. These are statements that are always true regardless of what value of variable you use. So for example, x plus 3 squared always is equal to x squared plus 6x plus 9. It's not that we are looking for an x that makes it a true statement. It's always true. So this stands apart from that one, even though the same kind of notation is used. Both of them use this equal sign, but the intentions are different. Finally, a function. We have a function notation like y is equal to f of x. We have seen plenty of functions in this course, all the trig functions, exponential functions, logarithmic functions, polynomial, and so on. Here's an example of a function. A function has an input, traditionally called x, has an output, traditionally called y. It has a name for the function itself, a generic one, typically just called an f. And the formula for the function, well, it can be any formula. Okay, so the intention was to make sure we understand what is an equation. Next is, well, how do we actually solve an equation? Let's just go ahead, quickly review that one as well. Equations come in many forms. There are infinitely many forms of equations. We have only looked at maybe a few of these, just a handful of them. So typically start with a very simple equation, such as equation like this, 2x plus 3 equal to 0. Well, we call that the linear equation. Linear equation because when you consider the corresponding function, such as y equal to 2x plus 3, the graph of it turns out to be straight line. At any rate, a linear equation, I'm sure you have gone through that in middle school, and then you know how to solve it. All that I would like to see is that you speed up your style of how you approach this thing. So in preparation for calculus, you want to be quick in saying that x is minus 3 over 2. So if you have an equation like ax plus b equal to 0, with the quantity to look for being x, and a and b are some parameters like this 2 and 3, it should be immediate to you that x is minus b over a. So whatever process you go through in doing that, try to push yourself to speed it up to get to the correct answer quickly. Okay, next up we have so-called quadratic equations. Quadratic equation, these are polynomials with higher powers in them. So for example, starting with power 2, we have this example of quadratic equation. Quadratic equation. So quadratic simply means order or degree 2. That's what is referred to it. And the style of solving these things is by factoring and applying the zero factor theorem. So how do we factor these? We say this is a product of two linear expressions. So a linear expression here, a linear expression here. We try that out to see if that works. So I expect to have an x here and x here, and there will be two numbers. I look for two numbers. So what are these numbers? Well, whatever they are, when you multiply them, you are supposed to get 16. This times x and that one times that x means the sum of these two has to be 10. We look for two numbers such that the sum has to be a sum of 10 and the product has to be 16. So we do that by trial and error. So we say if the product is 16, it could have been 1 and 16, could have been 2 and 8, and could have been perhaps 4 and 4, and so on. And then we ask which one of them fits the bill of having the sum equal to 10, and of course 2 and 8 are the candidates here. So I get 2 and 8, and we double check to make sure everything fits. So yes, I do get x squared and 10x and 16, and then I'm all set. Now we apply the zero factor theorem. If a product of several items is 0, at least one of them must be 0. So that means either the first expression is 0 or the second expression is 0. So that gives us x equal to -2, and that gives us x is equal to -8, and our solution is -2 or -8. On Alex, when you enter this kind of situation, you separate them by commas. So it says give me a comma separated list of all possibilities, and then you write the answer in this fashion on that software. So -2, -8. Sometimes the problem becomes slightly more challenging. So for example, I could have, say, 6x squared plus 7x plus 2 equal to 0. This is more challenging because in the two parentheses that we are looking for, that 6x could come from 1 and 6, 2 and 3, 3 and 2, 6 and 1, and this 2 can also come from, well, in this case of 2, it's not that many choices, but the problem can get slightly more challenging. One way to handle this, and I'm sure you have come across this and you might have your own favorite way of doing this thing, is to take 6 and 2, multiply them, get 12. Now look for two numbers such that the sum, as before, is just the sum that we are looking for before, and the product is 12. Look for two numbers such that the sum is that number and the product is same as the product of these two numbers. Okay, so in the previous one that would have been 16 times 1, well, it's again 16 itself, and then you're all set. Well, this is for this particular case easy to guess. The two numbers are 3 and 4. But we don't use them directly. We have to still do some work. We write 6x squared. The middle term, we write it at two pieces, 3x and 4x. And then we write the 2. Now we factor by groupings, 3x times x, 2x plus 1. And this one we factor also as 2 times 2x plus 1. And then we factor the common factor again, which was 2x plus 1, and then the other one becomes 3x plus 2. So that final answer is 3x plus 2 times 2x plus 1 equal to 0. Either of these have to be 0, so we get x is equal to -2/3, and the other one is -1/2. So separate them by comma, and then we are all done. Sometimes we might look for factorization and nothing easy comes to mind. So for example, if I have x squared plus, let's write 2x squared plus say 7x plus say 1 is equal to 0, I might look for two numbers such that the product is 2 and the sum is 7, and might be stumped by that. So what is the solution in that case? The solution is to go after so-called completing squares, or the so-called quadratic formula. So the most famous formula in elementary algebra is the following. If you have the quadratic equation, then you go through completing the square, and out comes a formula for x, which is minus b plus or minus radical b squared minus 4ac divided by 2a. So that comes out of the process called completing the squares. And in this case, what we have is that x is going to be then minus 7 plus or minus radical 7 squared minus 4 times 2 times 1 divided by twice the first number 2. So if we simplify this, 7 squared is 49, minus 8 is going to be 41. X becomes minus 7 plus radical 41 divided by 4, and the other option is minus 7 minus radical 41 divided by 4. These are the two answers, and expressions with plus and minus, sometimes referred to as conjugate elements. We have an expression inside the radical. This is typically referred to as the discriminant. Discriminant discriminates between various possibilities. This is typically shown by letter delta. The possibilities is if delta is positive, if delta is 0, or delta is negative. So if delta is positive, we have two distinct roots. If delta is 0, we have two identical roots. If delta is negative, we have two complex roots. So this is two distinct this would be giving identical roots. In this case, we are going to have the so-called complex or imaginary roots, because you're taking square root of a negative number. So that is an issue to have in mind. Next issue is what if the equation that we have has a fraction in it? So suppose I have, say, 2x minus 3 over 5x minus 4 equal to 0. For a fraction, so a fraction has a numerator and then has a denominator. For a fraction to be 0, the numerator has to be 0, and you have to make sure denominator is not 0. Okay, because you don't want to divide by 0. So for that equation, you set 2x minus 3 equal to 0, and as before, you get x is equal to 3/2. So these were some basic facts about equations. We just quickly went over them to get ourselves ready. So what is it that we are going to do in this section? Our equations are going to have trig functions in them. So what we have in mind in this section is, well, what if I have cosine of x instead of just x, 2 cosine of x, say 2 cosine of x minus 1 equal to 0. What in this case, what angle satisfies this equation? And then there might be many possibilities. How do we choose one among many? So what for trig functions we typically restrict ourselves to the circle. So in that case, the problem might say find a solution so that your answer is inside that circle. Well, inside that circle means you are going from 0. You start at 0. By the time you come back, you are at 2 pi. And so sometimes they say, well, okay, stay inside this this range of numbers. Start at 0, and you can go as far as 2 pi, but perhaps not 2 pi itself, and so on. So we are going to look at a variety of examples in this regard. We need to know our table of trig values, or the trig values of special angles. We need to know how to use our calculator for solving this problem. We need to know our inverse trig functions and several other topics. So let's get ready and start that process. Until next time, good luck and God bless.